Hello, welcome to Tennessee's at-home learning series for math. Today's lessons will be for all of our fourth graders out there, though all children are welcome to tune in. This is the sixth lesson in our series. My name is Miss Pereira, and I'm a fourth grade teacher at Venus Stewart Elementary in Gallatin, Tennessee. I'm excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education website, www.tennessee.gov/education. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch the previous lessons since we'll be discussing similar topics. Today, we will be learning about composing fractions. In order to fully participate in this lesson, you will need paper, pencil, and an area for you to work in. I'll give you just a minute to gather those materials. We're going to think about composing or putting together fractions. A fraction is a number that names equal parts of a whole. We will also think about how to model our thinking about fractions by drawing pictures and models. So let's start with thinking about a whole divided into equal parts of twelfths. So when you think about the word twelfths, you're thinking 12 equal pieces. So draw this with me. We're going to draw a whole, and our rectangle is going to represent our whole. And we need to divide it up into 12 equal pieces, or twelfths. So I'm going to do this by making 4 columns. 1, 2, 3, 4. And then I'm going to go through and make 3 rows, because I know 3 groups of 4 is 12. And I will have 12 equal pieces. What fraction would name one part of the whole we drew? So one of these little pieces, what fraction could we use to name that part? Right, 1/12. Each one of these 1 parts represents 1/12 of the whole thing. That is our unit fraction. A unit fraction has a 1 in the numerator. And then the denominator always tells us how many equal pieces are in the whole. The numerator, the number above the line, tells us how many of the equal parts we have. So if we're talking about one of our pieces, we would have 1 out of 12. The denominator, the number below the line, tells us how many equal parts are in the whole thing, or the size of the pieces in the whole thing. Great job. Okay, so let's look at a word problem and really try to put this knowledge to use. So let's think about a deck of cards. And the reason we kind of started with this model of breaking up a whole into twelfths is because our deck of cards is going to have 12 cards in the entire deck. Lynn, Paco, and Todd share a pack of 12 cards. Lynn gets 4 cards, Paco gets 3 cards, and Todd gets the rest of the cards. What fraction of the pack does Todd get? So, ask yourself 2 questions. What do we know? What information did it give us? What do we need to know? So let's go back through and dig out what we know, pulling out that important information that's going to help us solve this problem. So I know that there was 3 people who shared the pack of cards. I know Lynn got 4 cards, Paco got 3, and Todd got the rest. So it didn't exactly tell us how many Todd got. That's what it wants us to find out. What fraction of the pack does Todd get? So I like to pull out my important information and record it on my paper. And I'm going to color code so I can easily keep track. So I know that Todd got the rest of the pack. So I'm kind of leaving a blank for him right now because I don't know exactly how many cards he has yet. It told us that Paco got 3 cards from the deck. And it told us that Lynn got 4 cards from the deck. And we know that there were 12 cards total. So kind of pulling out my information and organizing it here helps me as I think through this problem. So we could draw a model to help us visualize this. I'm going to try my best to draw 12 even squares, each square kind of representing a card in the pack. So eight, 9, 10, 11, 12. And I can go through and label these cards as to who got what. We know that Lynn got 4 cards. So I'm going to go through and label 4 of them with an L for Lynn. We know that Paco got 3 of them. And we know that Todd got the rest. So that must mean that these cards that I haven't labeled yet belong to Todd. So I'm going to go through and label those with a T. So I can see now that Todd got 1, 2, 3, 4, 5 cards out of the deck. So now we know how many cards they each got, but the question asked us, what fraction of the pack does Todd get? So saying that Todd got 5 cards doesn't really answer that question. We have to put it in a fraction. So I know that each one of these cards represents 1/12 of the deck. 1/12, 1/12, 1/12, and so on. So I could say that Todd got 1/12 plus 1/12 plus 1/12 plus 1/12 plus 1/12. So that altogether he got 5/12 of the deck. So that answers our question. Paco got 3 of the cards, 1/12, 1/12, 1/12 of the entire deck. So we could write his addition equation like this. He got 3/12 of the deck. And Lynn got 4 cards, 1/12, 1/12, 1/12, 1/12, and we put them all together, we can see that Lynn got 4/12 of the deck. Great job. So we were able to use that unit fraction to help us build our understanding of how much of the fraction of the total deck that Todd got. So we could answer in a sentence because the question said, what fraction of the pack does Todd get? So we could say Todd got 5/12 of the pack. Great job. So we talked that we were going to compose fractions. So that's what we just did. We built or composed 5/12. We put 5 1/12 together to make a total or a sum of 5/12. We put 3 1/12 together to make a total or a sum of 3/12. We composed 4/12 with 4 1/12. So let's look at another one. This time I want you to think about a fence. Kind of picture that in your mind, a fence. And we've got some friends who want to paint a fence. And we know that their fence is divided into 10 equal sections, or we could say it's divided into tenths. So draw this one with me. And let's draw a rectangle to represent our fence. And we need to break it up into tenths or 10 equal parts. And I like to do this with starting by breaking it up into fifths and then going back and splitting those in half. So there's fifths, but I don't need fifths, I need tenths, so I need to split them in half again. So that now I have a fence split up into 10 equal sections. So what does this one piece, what fraction could we use to name this one section or one part of fence? Correct, 1/10. And then this one section of fence would be 1/10. This one section of fence would be 1/10, and so on. That's our unit fraction. Each piece in the whole represents 1/10. And I'm going to tell you we've got two friends painting this fence. We've got Josie painting some on the fence, and she wants to paint 3 sections of the fence. And we have Margot painting some on the fence. And she wants to paint 4 sections of the fence. So think in your brain, what fraction of the whole fence did Josie paint? What fraction of the whole fence did Margot paint? Let's use our model to help us. So Josie painted 3 sections. So she painted this section, she painted this section, and she painted this section. So how many of those 1/10 sections did she paint? Correct, 3. So we could say that she painted 1/10 plus 1/10 plus 1/10 for a total of 3/10 of the fence. What fraction of the fence did Margot paint? So we know that she painted 4 of the sections. So we can do some shading to model that. 1 section, 2 sections, 3 sections, 4 sections. So what fraction of the fence did Margot paint? Great job, 4/10. She painted a 1/10 section 4 times for a total of 4/10 of the fence. And you can see they've still got some fence left that needs painting, right? So looking here at Josie's fraction, 3/10, what does the numerator, the number on top, represent? Correct, it represents 3 of those 1/10 pieces. What about Margot's? What does her 4 as the numerator represent? Correct, 4 of those 1/10 pieces. And you notice they both have the same denominator because they were working with the same equal size pieces in the same whole. Great job. Let's continue our work. Let's look at a pizza. So a lot of times when we start talking about fractions, everyone always brings up pizza. I think it's a little bit more difficult to draw a model for pizza, especially if it's a round pizza, but it is an option, so we're going to look at that one today as well. Do you like pizza? I love pizza. My favorite is pepperoni and pineapple. This time, our pizza is going to be cut into 8 equal slices. So using a unit fraction term, what would that be? 8 equal slices. Right, it would be split into 8s. So let's go ahead and draw our pizza. I want you to draw it with me. Draw a circle big enough that you can split it up into equal parts. Don't draw it too small or it'll be hard for you to do that. I'm going to try my very best to get a nice, neat circle because fractions are equal pieces of a whole. So we need to make them look as equal as possible. And we're going to split it into eighths. And the best way that I can do this is to split it into fourths, which is pretty simple. And then I can go back and split those pieces in half. Great job. So what fraction can be used to describe each slice? So if I had one slice, what fraction could be used to name that piece? Correct, 1/8, because it's 1 out of 8 equal pieces. What fraction could I use if I just ate this one slice? Correct, 1/8. Every slice in this pizza is the same size. It's the same part of the whole. They all represent 1/8 of the whole pizza. So that's our unit fraction with the 1 in the numerator that tells us what size each unit is. What fraction could we use to describe the whole pizza? So if I ate the whole pizza, I could say I had one whole pizza. But 1 is a whole number. It's not a fraction. So what fraction could I use to say that I ate the whole thing? Right, 8/8. I ate 8 out of 8 pieces. I ate all the pieces. I ate the whole thing. We could write an addition sentence to match that. I ate this piece, then this piece, then this piece, then this piece, then this piece. Until I ate 1, 2, 3, 4, 5, 6, 7, 8 out of the 8 pieces. What if I only ate 3 pieces? I ate this piece, and I ate this piece, and I ate this piece. So those pieces were taken away. What fraction could I use to name the 3 pieces that were taken away? Correct, 3/8. 3 out of 8 pieces. As an addition equation, it would look like this: 1/8 plus 1/8 plus 1/8. We were able to compose or build that 3/8 with 3 of the unit fractions. Okay, I'm going to let you try one on your own this time. And it has to do with some cake. So let's read the problem together and give you a few minutes to really look at it. At a party, you're giving out 8 pieces of cake. People will get different amounts of cake. Tom gets 1 piece of cake. Hal will get 1 piece of cake. Mary will get 2 pieces of cake. Nancy will get the remaining pieces of cake. What fraction of the cake will each person eat? Write an equation to match the situation. So you can kind of think about when we did the playing cards earlier. We said, what fraction of the pack did Todd get? And we went through and said, what fraction of the pack did Paco get? What fraction did Lynn get? So this time, instead of cards, we're looking at what fraction of cake did each person get? So go ahead and pull out that important information that you see and draw a model to help you. I'm going to give you 2 minutes to work this on your own. a little bit less than a minute. Great job. Okay, so what do you think? What fraction of the cake will each person eat? Let's check our work together. So I always like to start with pulling out my important information. So I know that Tom got 1 piece. I know that Hal got 1 piece. I know that Mary got 2 pieces. And that Nancy got the remaining. So I'm not exactly sure how many pieces Nancy got right off the bat. And I know because it told me in the first sentence you're giving out 8 pieces of cake that there were 8 pieces altogether. So I can draw a model to show that. So again, I'm going to start with my rectangle. I can just draw a rectangle way better than I can a circle. 8s, I always like to start by splitting it in half, and then I split my half in half to get fourths, and then I go back and split those in half to get eighths. It just helps me make sure they look a little bit more equal. And then I'm going to go through and label. Tom got 1 piece, so I know that's Tom's piece. Hal got 1 piece, so that's Hal's. Mary got 2 pieces, so those 2 pieces belong to Mary. And then Nancy got the rest. She must have been really hungry because we can see that Nancy got 4 pieces of the cake. But the question said, what fraction of the cake will each person eat? This just tells me how many pieces that they ate. It doesn't tell me what fraction of the whole that they ate. So I'm not finished just yet. So each piece that they ate represents how much of the whole? Correct, 1/8, because we had 8 pieces in the whole, and they each are 1 out of 8 pieces. So now I can go over here and write an equation to show how many pieces they had all together. There's no equation needed for Tom's. He simply ate 1/8 of the whole cake. The same for Hal. He simply ate 1/8 of the whole cake. Mary ate 2 of those 1/8 pieces for a total of 2/8 of the entire cake. And then Nancy, hungry Nancy, ate 4 of those 1/8 pieces. So when we add 1/8 4 times, we can see that she ate a total of 4/8 of the cake. Great job. So how does knowing equal parts help you add fractions? Breaking them up into those equal parts, those unit fractions. Right, adding fractions is simply joining those equal parts of a whole. We joined the 2 pieces that Mary ate to get the fraction that she ate. We joined the 4 pieces that Nancy ate to get the fraction of the amount that she ate. Now I'm going to show you your independent practice that is available for you to go back and do on your own once this lesson is over. You can take a picture of your screen. We went way too big. I'm sorry, just a second and I'll zoom out. Or you can go online to the tennessee.gov/education website and find this where it's available in a printed version. Let's trying to zoom in so that you all could see it. Went a little too far. So great work today. You've worked really hard to explore composing fractions. You did some amazing work. Now you'll have some problems here to work on your own, or you can find them online. As we close, I want to say I enjoyed doing math with you all. I'm so proud of how hard you all worked today, and thank you for inviting me into your home. There we go. Does the model below show 8s? Why or why not? Divide this rectangle. If you're just doing it on your own, just draw it on your own paper and then shade it to show 3/8 plus 2/8. And then you have 2 word problems at the bottom. Don't forget to draw models to help you understand what you're doing. Great job.
Hello, I'm Maria Lee, First Lady of Tennessee, and I'm so glad you're here. This has been an unprecedented time for our state and our country. I'm so proud to see how Tennesseans are coming together to serve and lift each other up in the midst of challenges. Each of us has a role to play, including you, our students. Right now, your school buildings may be closed, but there are many opportunities to keep learning. And we are so grateful for the partnership of PBS in bringing this program directly to you as one more way to keep us learning and growing together during this time. I want to also give a special thank you to all of the teachers who helped make this possible. We could not do it without them. Most of all, thank you for joining us.